Lazer Wars is a math game where each player or team commands a spaceship that moves through 2D space, defending itself from opponents by firing a laser beam in the form of a linear equation. Yeah, there are similar games available. If I had to choose one as exemplar, I'd pick the one you see now, Graphs of the Galaxy. Lazer Wars, however, will be different in 3 broad ways. First, we'll try our best to incorporate many math skills instead of 1 or 2. Second, we're primarily interested in a multiplayer, classroom-like experience. Third, we aim for the game to be freeware for classrooms without internet access. What's with all the "we" talk? This game is a work in progress. I'm going to show you how to play, but we don't have a packaged product yet. Save your gripes. This work is done in our spare time for posterity. You're welcome to improve upon the idea. When I play, it's with dropouts looking for a quick path to their high school equivalency. Their interest is minimal until you get them bantering. They need lots of practice, the kind that informs oneself that you're not as ready for the final exam as you think. We don't have a lot of money, yet we're resourceful. That's why this is an internetless pursuit. That's why my class plays on paper as I project my laptop onto a large screen. I prefer to plunge students into the game without much briefing. It's more entertaining, and I believe high school equivalency students learn better from revelation. So I'll quickly do the same with you. Please understand the purpose of this video is proof of concept, to introduce you to the game Lazer Wars. I expect you'll tailor it for yourself. In later videos, I will explore streamlining the game or adapting it. Right now, let's focus on the what and why before we discuss the how and when. Here's my prototype. First, I divide the class into teams, not more than 4 teams consisting of 5 or less people, best to match less savvy students with more savvy ones. Then I have the teams pick a color. While they're arguing over that, I pass out the graphing paper specified. Then I get each team to settle on a shape. I limit the area of each shape between 1 and 10 square units. It's their first game, so we need to make it simple. Team 1 gets to be anywhere in quadrant 1, Team 2 anywhere in 2, 3 and 3, 4 and 4. For this presentation, I've created a fictional example. Team Blues, consisting of randomly generated players Estelle, Guillermo, and Gerald, not so randomly selected a triangle. They calculated the area and perimeter correctly, and like all hypothetical students, even showed their work perfectly. Other teams turned in their paperwork. As instructor, I thoroughly evaluate their first submission, of course. We'll round the 9.66 down to 9. In early games, we round to whole numbers. Area calculations rounded up and perimeter calculations rounded down. Then I, as umpire, will record their input. This usually takes much time, so I pause the game until the next session of class. As umpire, I make a little summary for myself. Then I input their positions into some coordinate geometry software. This I'll explain later. I input commands to plot and color the polygons. Voila! Students' first game should be grossly simple and end quickly. Thus, I reveal it's a game. Their polygons represent spaceships at war. Each ship has laser cannons that, when entered correctly into the ship's computer, will damage targets. I then begin to publicly coach each team through their first volley of lasers. Students typically start asking questions at this point about the purpose of the game, its rules, and so forth. I remind them this is their first rodeo. We're going to go slow so each team can get a tutorial. Normally the game is what's called a simultaneous action selection game, like rock, paper, scissors, where everyone plays their turn at once. What's important right now, I tell them, is to observe and learn. I distribute paper forms of the game's mission dossier, pictured here. I explain this is the input they'll submit to their ship's computer, to me, the umpire, for each turn in the game. Not the coordinate graph paper, that's for their scratch work. So, to make the point, I return their initial paperwork and direct them to put that info on their new mission dossiers. It's a quick data entry task. They must specify their team color, they must enter their coordinates correctly, enter the area of their ship as HP, and the perimeter of their ship as FP, which I'll also explain later. I query a team to report to me and the class their progress, in the style of the game show Family Feud. I've chosen team goals in advance. If they correctly report each value, I end by acting like they have beginner's luck. I'm keen to emphasize there will rarely be mulligans. When the deadline is due, nearly all mistakes on the dossier will get locked in. If students ask why, I point out that normally their turn will happen at the same time as another team's turn. Therefore, be careful and plan in advance. Occasionally, a student wants a storied explanation, like why spacefaring people with engines, gadgets, and lasers would be dumb enough not to be able to adjust in real time. That's really thought-provoking, I respond to the gadfly. You know what? Let's turn that into a creative writing exercise. In over 500 words, craft an explanation. I'd do it too, because in my class they'd have a weekly writing exercise anyway. But that's beyond our discussion here. Be sure on the dossier teams specify their turn number. In this case, it's their first turn. Okay, now we can proceed with the tutorial for laser cannons. The first to be conscripted in this fictional example is Team Blues. They decide to throw all their firepower at Team Greens, the green rectangle. What point on the grid does Team Blues desire to target? They respond -4, -1. What point on the grid do they want to fire from? I explain laser cannons track along the entire surface of a ship. Thus a laser may emanate from any grid point the ship occupies. They decide the laser should originate from -7, 2. What will their angle of attack be? I direct them to aim a linear equation in slope-intercept form. The team deliberates. They ask if this is permissible. I reply, yes, so long as you simplify it. They clarify y equals -1x minus 5. How powerful do they want the laser to be? I technobabble some explanation how a ship's power is derived from fission power cells that orbit the ship's perimeter via supermagnetic field. Thus, larger perimeters generate more power than smaller perimeters. Blues has a perimeter of 9 units, so they can spend that much per turn. They agree to do just that. Direct hit. Team Blues spends 9 FP, as in fission power cells. Team Greens loses 9 HP, as in hull plating. What will happen to Team Greens? Find out next time on Lazer Wars! Lazer Wars is brought to us through GeoGebra. There are a number of math graphing freeware. Few are as powerful. Only GeoGebra has an offline version. Plenty of resources at geogebra.org. Before the break, Team Greens was in peril. They lost 9 HP due to laser damage. Unfortunately, that's more than their hull plating can sustain. Because how did we calculate HP? The area of the ship is less than 9. This is for the dossier for Team Blues, so we need the area for Team Greens. Here's 1 square unit, 2, 3, 4, 5. 5 is less than 9. That's right, the area of a ship determines its health, HP, which we call hull plating. The perimeter of a ship determines its firepower, FP, which we call fission power cells. Under normal play, fission power cells FP recharges for each turn while hull plating HP does not. This is crucial for strategy as area and perimeter, you'll recall, were/are initial player choices. Sometimes students trip over which does what. I think some fiction of how the lasers and the hull plating interact helps. Power cells charge up as they orbit the spaceship. Laser blasts are diffused over the hull surface by hull plating. That's why perimeter and area of a ship are respectively important. If the laser power, FP spent, is equal to or greater than a target's hull plating, HP, the target is irreparably damaged, as demonstrated here. Yes, Team Greens is done for. However, remember that this is a simultaneous action selection game. Greens still gets to fire their laser. They still get their turn. We essentially paused the game for this tutorial. Predictably, Team Greens then quietly scraps whatever plans they've made and quickly schemes revenge. In this instance, they are sure to submit Blues' extermination. They also decide to throw their remaining FP at golds, something to remember them by. What I like to do at this point is display all the dossiers first before displaying the battlefield. It builds suspense, so I solicit Team Gold's their play for their turn. They wisely ask if lasers are all the ship's got. They know it's game over and everyone lost. Gerald on Team Blues tries to argue that Green's laser blasts the same coordinate as Gold's laser source, therefore Blues shouldn't be damaged by it. Good proposal, Gerald, but your ship's hull still breaks apart from Green's. Darla on Team Gold's prods again with their earlier question, are lasers all a ship's got? Since the class seems ready to move on to greater things, I inform them they could repair the ship. Much to the consternation of Green's, take it easy guys, this is just a demo round. FP can be spent to recover lost HP. Send a repair crew to a damaged section of the ship. By turn's end, that amount of FP power cells becomes HP, hull plating. Umpires shouldn't allow repairs on the first turn though. Recall that all dossiers, all turns, are happening at once. In this case, it's unlikely that Golds would have predicted where to send the repair crew. Had they survived, they could have done so on their next turn. There are other nifty gameplay elements like shields, which reduce laser damage, torpedoes that disable shields, and movement, of course. Future videos will discuss them. Keep in mind, though, this is all yet to be finalized, because I don't have the skills to publish the game. For starters, I can't figure out how to manage the game's ledger inside GeoGebra, which is based in JavaScript. Of course, Lazer Wars doesn't have to utilize GeoGebra, it's simply the platform I started with. Thus, we need your help. Anyone willing is welcome, especially coders. The goal is to have a program that will handle the burden of managing player input into a user-friendly presentation of outcomes. Umpires shouldn't have to calculate, for example, if the area of a polygon is indeed what a player claims, or if a line segment actually intersects with a polygon, or what the score of the game is after 7 turns. That's what computers are for. We need a tool that will help referee. What will happen to our intrepid intrastellar polygons? Find out next time on Lazer Wars!